Okay, so having a look at this question, what we're going to do, we're going to go through this first part that we've got together and remind ourselves how we've done some of this implicit differentiation. So I might just shrink this down a bit so I've got a bit of space to work on. And then we're going to try and predict what the question is going to ask us. So with this that we have here, we've got x squared minus 2xy plus 3y squared is equal to 50. So the x squared is going to differentiate to 2x. I wonder if anybody is able to do this without actually writing down the product rule, because that's something you might build towards in the future. Go on then, Hamza.
Minus 2y minus 2x divided by did not count.
Did you do that using u and v when you wrote it down, or did you do that in your head?
U and v, but I kind of know it.
Because what you can see that's happening here is, for this first part, the y has stayed and the 2x has differentiated, or the minus 2x has differentiated. Then for this part, you can see the minus 2x has stayed and the y has differentiated. So I didn't want you to do that at the beginning, but eventually, either at the end of year 13 or if you're at university doing like engineering, you're probably not going to want to write down u and v. And if you're doing further maths, you're going to be doing so much product rule that you need to be able to do it without writing down u and v. And Amara, what was the silly mistake that you made here? Yeah, you had that 50 differentiated to 50, but obviously it has to go to 0 here. And I haven't done the 3y squared either, so I've made another silly mistake. So that should go to 6y dy dx, and the 50 differentiates to 0. So then we can actually factorize straight away. So we've got 6y minus 2x, and we can put these onto the other side. So we've got 2y minus 2x. So dy dx is 2y minus 2x over 6y minus 2x. Last step that can be done, divide by 2. So we just get, or simplify by dividing by 2. So we get y minus x over 3y minus x as the question required. That's fine, that's just like stuff that you've done from your homework. This is actually from one of the new spec exam questions, so it's the kind of thing that you might see popping up. So what do you think is going to happen in part B or part C of this question? Yeah, it looks like this diagram that they've got here. They've obviously indicated something about P and something about Q that they've got here. And they're going to ask you to find out the coordinates of P and the coordinates of Q. Have you got any ideas about what kind of strategy you might be able to do to find those coordinates of P and the coordinates of Q? What do you notice about where P and Q are? Pardon? They do look like turning points, don't they? But when we describe turning points normally, we normally talk about turning points as 0 gradient, that we'd have maybe like here and here. So they're some kind of turning point in a sense, but they're not the turning point that we talk about traditionally. Nahid, what do you think? What's parallel? You can't just say they're parallel. Yeah, good. And you can actually kind of see that already. You can see that they've drawn like a tangent here and a tangent here, and they're parallel to each other. So that's one of the facts that we can notice. So if the tangents are parallel, then their gradients must be the same. But what are the values of the gradients at P and at Q? Yeah, we might sort of like colloquially say that they have an infinite gradient because they're going vertically upwards. But actually, when something has a vertical gradient, no, because a gradient of 1 looks like that, doesn't it? A vertical gradient, sometimes we say that it's infinity, but actually what we say is that it is undefined or not defined for the gradient. Because it doesn't really make sense to say for one space that you move along in the x direction, because you can't move along one space in the x direction. So if something has a vertical gradient, we actually say that it is undefined. So we haven't even looked at what part B of the question says, but we have come up with a gradient function that we've got down here. When is this gradient function undefined? When the bottom is 0. Good. So actually, if we make the bottom of this thing equal 0, we get something divided by 0, which we know is undefined. Sometimes we sort of casually say, oh, that's infinity. That will correspond to when the gradient is infinity or undefined. So we kind of already now know what's going to happen in the next part of the question. So this is what we had from the previous part. I'm actually going to now show you what the question says, and we're going to work through this as an example for you guys to have in your notes, because this is a kind of a weird example, and I haven't found any other questions that look like this. So here it says they've added in some kind of fake real life stuff. They've said the curve is used to model the shape of the cycle track with both x and y measured in kilometers. I don't know why this needs to be about a cycle track. It literally is just the question, other than that sentence, doesn't really have much to do with a cycle track. It says the points P and Q represent points that are furthest west and furthest east of the origin, as shown in figure 4. Using part A, find the exact coordinates of the point P. So nothing really to do with the cycle track. All they're really saying is just find out what point P is. So I'm just going to kind of shrink this bit down a little bit, and we're going to use that and that for the bit of the question that we've got. So we just said to find out points P and points Q, we needed to make the bottom part equal to 0, because when you divide by 0, you get undefined. So if that bottom part is going to be equal to 0, we come up with that x is equal to 3y. Great. What are we going to do with that? Habib? Yeah? Tell me more. Yeah, good. We're going to sub this into this. That's the only option that we really have here. There's nothing left to do in this question. We've got an equation that we know is going to give us the answer for something being undefined, and we've got the equation of the curve. So we're going to substitute this into here, and we're going to see what happens when we substitute that in. This is often an interesting kind of technique that can happen. So I'm going to see if I'll do it down here. So we've got x squared, which is going to be 3y squared, which you must make sure you bracket it so that you make sure it's going to turn into 9y squared, minus 2, x is 3y, y, plus 3y squared equals 50. So you get 9y squared minus 6y squared plus 3y squared is equal to 50. What does that simplify to on the left? So 6y squared is equal to 50. So y squared is 25 over 3. Just simplified that a little bit quickly. 50 divided by 6. So y is equal to plus or minus root 25 over 3. And root 25 over 3 is 5 over root 3.
Which is 5 root 3 over 3.
Good, which is plus or minus 5 root 3 over 3. So that's what the y coordinates could be. Which one of these do you think is for P and which one is for Q? Yeah, you don't need to really explain why. You can look at the diagram and you can clearly tell that the P's y coordinate is negative and the Q's one is positive. The thing I probably also would notice about this is it kind of looks symmetrical in some way. It doesn't have reflective symmetry, but it's got that rotational symmetry where this distance down here looks equal to this distance up here, which is nice because of the fact that it's plus or minus. So for P, what would the x coordinate be? How would you find the x coordinate? No, don't sub it back into the main equation. Yeah, look, x is equal to 3y. So this is just like a really souped up version of doing simultaneous equations, but you didn't really know that it was simultaneous equations. So the x coordinate is 3 times the y coordinate, which means the x coordinate is, are you sure? It's negative 5 root 3. And the y coordinate is negative 5 root 3 over 3. I'm going to really quickly just put this whole question on Desmos so we can see what it looks like. So we've got, can someone read out the equation? Is it x squared minus 2xy plus 3y squared equals 50? And the coordinate we just said was 5 minus 5 root 3, yeah, minus 5 root 3, and then minus 5 root 3 over 3. Put that on projector mode so we can see it a bit more clearly. And then clearly we can see we've worked out this point that's here. Similarly, we could have worked out what this one over here was, right? Now, part C of the question says, explain briefly how to find the coordinates of the point that is furthest north of the origin. You do not need to carry out this calculation. So how would you do that? Just tell the person next to you, how do you think you would find the point that is the furthest north? Give you like 15, 20 seconds to decide how would you find the point furthest north instead? So furthest north, I'll give you hints, this bit up here. Okay, so what would be our way of finding the point at the top? What's the gradient over here? The gradient here is 0. That would have been the easiest one to do. So all we would need to explain for this part at the bottom, explain briefly, you would say dy by dx equals 0. So what would be true from this thing? So y minus x is 0, because remember it's the numerator that's important for when it's equal to 0. So you get x is equal to y. Then I would say substitute this into the equation and solve it to find the coordinates. They say explain it, you don't need to do it. It's almost easier to do it than to explain it. Do you know what I mean? For 1 mark to have to explain that, I'd rather actually just do the work myself. But I guess we have to do it like that. So this idea of solving something and having to substitute it back in, you're going to have a couple of questions where you can do one of the questions might involve this. So on your next page here, you've got 2 exam questions. The first one's a little bit easier. The second one is a little bit more demanding. So I'll pause here and see how that goes.